Welcome to our new unit on measurement and stoichiometry. We're going to start this unit by taking a look at scientific notation. When scientists take measurements, oftentimes numbers get very, very large. For example, measuring the distance from Earth to the nearest star, well, it's this many kilometers. That's a really big number. Sometimes in science, numbers get very, very small. For example, when we look at the hydrogen atom and we want to know its radius in millimeters, well, it's this number. It's a very, very small number. Sometimes it's not very convenient to read a number like this, 0.000000106 millimeters. So we have a different way that in science we write numbers like this. We can create a much more meaningful representation by using scientific notation. Any number can be written in scientific notation, regardless of the number. And we write the number basically as the product of two numbers, the product of a number between 1 and 10 and a power of 10. That means we're going to multiply one number that is between 1 and 10 by a number that is a power of 10, 10 to the something power. Here's an example. Here's this very large number, okay? It can be written as, instead of 39,900,000,000,000, we can write it as 3.99 times 10 to the 13th. So how do we do this? How do we figure out how to do this? Let's take our very large number, okay? And we write the very first factor as a number between 1 and 10. So we take this large number and we move the decimal point to a place that creates a number that is between 1 and 10. That number would be 3.9. Actually, 3.99. I didn't write that other 9 there. How many times would you multiply this number by 10 to achieve your number? We would multiply it by 10 13 times. And then we can write that as our exponent of 10. So we can say 3.99 times 10 to the 13th. That means we're going to multiply by 10 13 times. If we do that, we get this number. This is just a much easier way to think about it and to write it. So now you try one. Write this number, 460,000, in scientific notation. If you answered 4.6 times 10 to the 5th, you were correct. Now what about small numbers? We said small numbers also can be written this way. Let's look at our example, okay, our atomic radius. We can use the exact same rules. First, we write the very first factor as a number between 1 and 10. So where can we move this decimal point to create a number between 1 and 10? We can move it right there, 1.06. Now, how many times would you divide this number by 10 to achieve your number? So here, note that we will be moving our decimal to the left. We're going to be dividing by a power of 10. So our exponent is going to be negative. We're not multiplying, we're dividing. So we write 1.06 times 10 to the negative 7. You try writing the following numbers in scientific notation. Remember, when you move the decimal right, the exponent is positive. When you move the decimal left, the exponent is negative. So you try these examples, and I'll give you the answers on the next frame. Here are our answers. Recall, 4.2 times 10 to the negative 4. That means if we move this decimal place to the left, because it's a negative 4, we're going to move it to the left 1, 2, 3, 4, and that gives us this number. What about this number, 5,200? Well, 5.2 would be our first factor, times 10 to the third, because when we take the decimal point and we multiply by 10 3 times, we get this number. Same thing here and same thing here. So if you would like to demonstrate advanced proficiency, try demonstrating adding, subtracting, multiplying, and dividing by numbers written in scientific notation. You will have to use some rules for exponents and division and multiplication, addition, and subtraction with those. So I look forward to seeing you in class, and good luck on your scientific notation.